66 Ninja Pong Warriors. I'm Davide.
I'm Aditya. And I'm Michael.
So the goal of this project is to create an interactive educational tool for engineering and physics students at the high school level. We've undertaken significant customer research to develop a list of needs, and from that, a list of specifications which our engineers are working with to create an effective and valuable product. We've provided an economic analysis to underscore the profitability of this for VTEPs and have outlined an overall trajectory for the further development of this project.
The product description for this project was to create an interactive teaching educational toolkit that students can buy. We have specifically focused on 11th grade physics students, and will cover topics including projectile motion, conservation of energy, and basics in circuits. This is a completely new product platform, and it will be using existing technology. This has several benefits. A, we will be able to create a completely new product platform where VTEPs can create a new next generation of products on, either in the same field or teaching different things, using similar tools from what we're developing today. We'll be using existing technology such as Arduino's 3D printing technology and motors, and anything that can be bought off the shelves. This will be a low risk for the engineers, and we can just work on building a better product that really addresses our key business goal, which is to create a very customer-oriented product. We want to bring a lot of educational value, short and long term, in this product, and we want students to be really engaged, learn these three concepts, and be asking questions, and really visually memorize what is going on over here. Currently, the team is on completing the concept generation phase, and we're about to be moving on into concept testing. The engineers have already designed a obstacle 1 prototype and have rough design sketches for obstacles 2 and 3. As for the customer needs, we conducted several interviews and messaging old teachers for feedback, and we found out one of the key needs for the customers was to have a relatively inexpensive product that was at least cost effective for the amount of educational value that it would have provided to the students. We wanted this product to be easy to carry, easy to take out of our car and take from class to class, hence it couldn't be very heavy or size too much. And also it should be easy for setting up. We want the product to be almost plug and play with minor needs for setting up or calibration. This product as a whole must definitely be challenging for the students. We want them to be learning science and engineering concepts, hence we have chosen physics. And we will be doing this through use of circuits or puzzles and visual aids for the user. The product must definitely be well packaged overall from purchase as well as for storage, and allowing this product to last a longer time. And in use, it must not be extremely loud so as to disturb people nearby. The product must definitely be safe at all times. Teachers emphasize that students are in the classroom and must be not be carrying too much voltage in the circuits or containing sharp, dangerous parts that are at reach. And final needs emphasized by customers was reliability. This is not a one-time use educational toolkit. This is an interactive toolkit that will be withstanding a lot of use over time and hopefully last about 5 years, so that a teacher can teach at least hundreds of kids through this one demonstration and last a decent amount of time.
So in striking a balance between some of these subjective customer needs and more objective and easily measurable metrics, obviously compromises had to be made. We believe these are fair compromises, and they give VTEP's company a method for gauging the overall progress of this project. Of course, higher technical importance was placed on those metrics which more strongly correlated with the needs of the customers, specifically the cost, the educational merit, and the interactivity of the project. The difficulty in measuring certain metrics, specifically the educational merit, shifted the priority in the final specifications, which we have listed here, which, as you can see, are mostly physical in nature and more easily measurable.
Here we have our team's economic analysis. Through rigorous customer research, we have determined an optimal selling price of about $150 per unit, with an inclusion of a 10 cent per sale lowering of the price. We've determined our estimated cost to be $55 per unit. That includes items such as the Arduino board, resistors, and 3D printed components assembled together. We found our first break-even point to be at 125 sales, that is highlighted in yellow. We found our second to be at 826 sales, which is highlighted in green. However, however much profit we can make at any sale quantity in between those two, we found our optimal selling point to be at 475 sales, making us a profit of $12,262.50. In summary, we are designing a product to become a basis for new platforms of educational kits. We're bringing together extensive customer research and affordable price targeting. And as a result, our preliminary expectation is that we will profit $12,262.50. And we even expect this margin to improve as time goes on when we enter the design for manufacturing phase and investigate new methods of manufacturing that are perhaps more cost efficient. And moving on from here, we will enter a rigorous testing of our concepts in the concept testing phase.
Are there any questions?